Speaker, while he's getting wired up over here with his microphone, tell you a little bit about Bill Harlan. Bill Harlan started his new job as Public Information Officer at Sanford Underground Laboratory at Homestake on March 11, 2008. For most of the previous 28 years, he was reporter in the Black Hills, including 22 years with the Rapid City Journal. His first beat at the Journal was City Hall, when it was located at 30 Main Street. Bill wrote more than 100 stories for the Rapid City Journal about the proposal to convert the Homestake gold mine into an underground laboratory. He was interested in the story because he had worked underground at Homestake. In fact, in 1968, Bill helped lay railroad track to Dr. Ray Davis's Nobel Prize-winning neutrino detector, 4,850 feet underground. The interesting thing is that this is kind of doing full circle for Bill. Now Bill is helping to reopen the mine for science. The first major experiment is being installed in the very same cavern excavated by Ray Davis. As communications officer for the South Dakota Science and Technology Authority, Bill is still writing stories and taking pictures. He works with media, publishes newsletters, manages the Sanford webpage, and organizes events such as public lectures and the annual Neutrino Day Science Festival. Bill Harlan grew up on the East Coast, but has lived in the Black Hills since 1976. His great-grandparents settled in Lawrence County in 1890, and his mother grew up in Deadwood. He's originally from New York. He currently lives in Rapid City with his wife, Marjorie. Ladies and gentlemen, please give a nice, warm Rapid City welcome to Bill Harlan. Do a sound check. Can everybody hear me okay? Excuse me. Well, it's certainly a privilege to be here, and I'm here not without a little bit of nervousness and trepidation. As I look around the room, I've covered city government for quite a few years, and I'm sure I've misspelled quite a few names in this room. I hope you won't hold that against me. In 2008, March of 2008, I got an opportunity to leave the Rapid City Journal and become communications officer for the Sanford Underground Laboratory at Homestake. And it turned out to be a wonderful opportunity for me, and I hope that the lab turns into just as good an opportunity for the people of the Black Hills. I think it'll have a huge impact, not just on Lead and Deadwood, but throughout the Northern Hills and certainly even Rapid City. So what I'll do today is kind of go through just a quick update of what's happening at the lab. I'll describe a little bit about Homestake, and I think I see maybe some people with some Lead connections who will already know some of this stuff. And then I'll talk a little bit about how the project was nearly killed and how the state of South Dakota rescued it. And then I'll talk about what the NSF is doing and where we go from here and what kind of an impact the lab might have on the Black Hills. So this is just to orient you a little bit. This is Lead off to the right here, and on the top of this ridge is what used to be the Homestake gold mine, and is now the Sanford Underground Science and Engineering Laboratory. This is the Yates shaft over here on your left, and this is the Ross shaft head frame over here on your right. Each of those goes down about 5,000 feet. From the air, I think this is kind of an interesting picture. There's the open cut. That's the Grizzly Gulch tailings impoundment up here, which is still owned. Both these properties are still owned by Homestake Mining Company, and this is essentially the lab in between those two geographical features. So the Yates shaft head frame from Highway 385, and the Ross shaft head frame from the Yates shaft. And this is a very simplified schematic that's not exactly correct, but it's a simplified way of looking at the Sanford Underground Lab. The Yates shaft and the Ross shaft, you can see the Yates drops down, straight down 4,850 feet. This is a very important level, and I'll talk about that in a couple minutes. This is the Ross shaft, which actually goes down to 5,000 feet. And underground shafts that don't break the surface are called a winze, W-I-N-Z-E. And so this is 6 winze, and that's one of the major winzes that accesses the 8,000 foot level. That's the bottom of the mine. Actually, you can go about 8,150 underground, but that's just a sump. There's not really a level down there. So why go underground? This is why. This is background cosmic radiation, and this is bombarding the Earth 24 hours a day and night. Mostly it's protons, and protons hit the atmosphere, and they hit other particles and change into other particles, and I'm not going to go into a lot of detail here because the deeper I get into this subject, the more mistakes I make. But we're all awash in background cosmic radiation. We go underground because it's quiet down here. So if you want to detect really subtle, hard to detect phenomenon like neutrinos, you go underground. Neutrinos are subatomic particles that are almost impossibly small, and they play a big role in the history of Homestake and in Homestake's future. We're awash in neutrinos, mostly from the sun right now. As I'm speaking, about 100 billion neutrinos a second are going through my thumbnail. And you can, so it's just a constant, they call it the neutrino flux. It's a huge wash of neutrinos, but they're so small and they have no charge, they rarely ever hit anything. So most neutrinos we never notice them. And if you wanted to stop a neutrino, let's take an X-ray for example. An X-ray can penetrate about this far. To guarantee stopping all the neutrinos that are coming through us right now, you'd need a sheet of lead that was a light year thick. So neutrinos are very difficult to detect because they never interact with anything. But occasionally, very occasionally, neutrinos will hit something and make a very, very slight noise. It's almost, you can think of it as a slight flash of light. And scientists are interested in this, and so enter Ray Davis, who was a nuclear chemist at Brookhaven National Laboratory. And Dr. Davis wanted to study solar neutrinos, and he thought if he could go deep enough underground, he could get a quiet enough environment, and if he had a big enough detector, that he could catch or see the odd neutrino collision. So why Homestake? Well, this is a more detailed schematic of what the Homestake mine looks like. Here's the Yates, here's the Ross, here's the open cut, and this is just a big chunk of rock essentially. You can see how they started mining up here and they kind of followed the gold at about a 65-degree angle, deeper and deeper and deeper. This is about 3.5 miles from here to here, and it's about a half-mile wide. You can't see that dimension here, and it's about 1.5 miles thick. So it's a big chunk of rock with Homestake. There's about 370 miles of tunnels underground and 14 shafts. So it's a huge infrastructure. And back in the mid-60s, Ray Davis thought if I put a detector right here at the 4850 level, most of the cosmic radiation will be blocked. And he devised a detector that he thought in this quiet atmosphere, I can detect neutrinos that are being produced by fusion reactions in the sun. So he persuaded Homestake Mining Company to build him a couple caverns. This was a control room that they mined out for him. And this is the cavern for his detector. And that's Ray Davis standing at the bottom of it. And then he lowered the detector. This is the Yates cage. And essentially we're using the same cages today as they were in 1965. And they loaded it piece by piece and reassembled this huge tank. And I noticed some emergency responders here, and Jerry Wright in particular. And can you imagine if a scientist came to you today and said, could you build a giant cavern almost 5,000 feet underground for me in the middle of your gold mine? I want to put a tank in there that contains 100,000 gallons of perchloroethylene. And Homestake said, sure, that sounds like a good idea. That's essentially dry cleaning fluid, but a big tank of chlorine atoms is what it really was.